Newton's law of motion. Law of inertia. Newton's first law, the law of inertia, expresses that an object will remain in its present status except if there is an adjustment in its equilibrium caused by an even outside power. In the given definition, balance is expressed. Equilibrium is balance. The condition of an object's equilibrium is known as its inertia. Inertia is best characterized as the opposition of an item to change its condition of movement. In the event that increases speed is missing, the object is in a condition of rest. Assume we have a man pushing a vehicle with a motor issue, with two travelers. From its underlying rate of 0 meters, the vehicle fired up to 80 meters in only 6 seconds. The man who was battling to push was in a condition of rest. However, when the vehicle began to fall forward in light of the fact that his body started to move from 0 to 80 meters, a similar second that vehicle started to run. There are two conditions in such situations to decide an object state. As found in the inverse, in the event that powers are adjusted, the power will stay in its present status. Returning to the past model, since the two items are very still, all powers are adjusted. Yet, since the movement was presented, there was an irregularity between the two. Accordingly, the man started to fall forward. Regularly, there is additionally a state change when one object moves a single way, yet an outer power keeps on altering the object's course.
The next Newton's law of motion is the power and the free body diagram. Newton's first law acquaintance, the idea of power, will portray its idea. As you were educated previously, you definitely realized that a power is either a push or a draw. Be that as it may, these days, it isn't generally the situation. In this way, what is a power? At that point, power is characterized as an impact that will in general change an article's state of movement when left unopposed. It can likewise be characterized as strength or energy, which result for actual activity or development. From that point, we have two sorts of powers.
Contact force or force that two objects exert whenever they are perceived as physical contact. Example of these forces includes friction. Friction is the resistance to motion of one object moving relative to another. Tension force. Tension force resulting from pulling. Normal force. The normal force is perpendicular to the surface in contact. Air resistance. Force exerted by air. Force that slows down falling objects near the atmosphere and surface area of the object. Spring force. Force resulting from compression. Applied force. Applied force directly applied to objects. If a person is pushing a box across the room, then there is an applied force acting upon the object. The applied force is the force exerted on the box by the person.
Non-contact forces, on the other hand, are forces that two objects exert at a distance. Examples are gravitational and electromagnetic forces. Gravitational force simply weights.
Law of acceleration. Newton's second law says that when a constant force acts on a massive body, it causes it to accelerate, to change its velocity at a constant rate. In the simplest case, a force applied to an object at rest causes it to accelerate in the direction of the force. However, if the object is already in motion, or if the situation is viewed from a moving inertial reference frame, that body might appear to speed up, slow down, or change direction depending on the direction of the force and the directions that the object and reference frame are moving relative to each other. A is for acceleration, F net is for applied force, and m is for mass. Here is an example of Newton's second law. If the force applied to the carts are the same, the acceleration of the empty cart is greater than the acceleration of the loaded cart, while acceleration will increase when a larger force is exerted. The acceleration or change in velocity of an object depends on the mass of the object and the amount of force applied.
Weight is a force exerted by the gravity on an object formulated with F small w is equals to m times g, where g is the acceleration due to gravity. Weight of an object is the result of Earth's attraction downward, which means weight is a downward force. Number 2, normal force. It is acting against weight, which is always perpendicular on the surface of an object is resting upon. Frictional force. It is the resistance of the surface or an object acting upon another object on contact with it. And lastly is applied force. It is a force directly applied on an object.
This law's premise is simple. There is always an equal and opposing, the amount of force counteracting against another force. In context, the third law explains the first and second laws. An example of this would be normal force, and it's the normal force is always paired with weight, which is the normal force's polar opposite. The two forces when paired together are called interaction force pairs. Other force pairs are applied force and friction, weight and air resistance, applied force and tension, and so much more. The law of interaction explains how things get to move. Say, a fish uses its tail to push away the water, but as explained by the other laws, water propulsion allows the fish to move forward. Another example is the interaction between friction, applied force, weight, and normal force when walking.